The forgotten emergency heating secret is not a $1,000 HVAC system or a $100 electric space heater that adds $50 to your monthly bill. It is 2 terracotta pots and a clay brick from any garden store for under $3. Position a small heat source like a candle on the brick. Place the smaller pot upside down over it with an air gap at the bottom. Place the larger pot over the smaller one. The heat creates convection between the pots, the high thermal mass. Clay absorbs and stores heat, then radiates profound lasting warmth throughout a room for hours using almost no fuel. $3 creates thermal mass heating, while electric heaters create thin synthetic heat that vanishes when power cuts. But before I show you the exact stacking technique, understand this critical point. This method uses open flame indoors. It produces carbon monoxide. It is a fire hazard. This is for emergency supplemental heating only, never as your primary heat source, never overnight, never unattended. You must have working carbon monoxide detectors, proper ventilation, and fire safety equipment. If you cannot follow strict safety protocols, do not attempt this. This is the lost blueprint. The residential heating industry is a $100 billion cartel built on grid dependency and planned obsolescence. An average American family spends over $1,500 just on heating every winter. The marketplace sells you portable ceramic space heaters for $100 that constantly suck expensive electricity, adding a hidden $50 monthly tax just to heat one room. But the real scam is these systems create thin synthetic heat that vanishes the moment electricity cuts. You just discovered thermal mass heating for $3, using the same principle Romans used in hypocaust systems and 19th century pioneers used in brick ovens. $3 versus $1,500 annually, plus grid dependency. The math is so absurd that the moment you see it, you will understand why the energy and HVAC industries completely buried the principle of thermal mass heating. They cannot create monthly recurring subscriptions around dirt cheap terracotta that retains and radiates heat for hours without power. But just knowing terracotta stores heat is only 10% of the secret. Today, I'm going to show you the exact convection mechanism that makes clay thermal batteries superior to electric resistance heating. I am going to show you how Romans and pioneers engineered lasting warmth without synthetic airflow. And I'm going to show you the critical safety protocols and ventilation requirements that determine whether this method provides emergency warmth or creates deadly carbon monoxide poisoning. By the end of this investigation, you will have the blueprint for emergency supplemental heating and understanding of thermal sovereignty. Let us begin. The science behind heating starts with understanding different types of heat transfer. There are 3 methods. Conduction is direct contact heat transfer. Convection is heat transfer through moving fluids or gases. Radiation is heat transfer through electromagnetic waves. Most modern heating relies primarily on forced convection. Your furnace heats air, and fans blow it through ducts. Electric space heaters use resistance coils to heat air that rises naturally or is pushed by fans. This creates immediate warmth, but it has fundamental limitations. Forced air heating creates what I call thin heat. The air gets hot quickly, but air has very low heat capacity. It cannot store much thermal energy. The moment your furnace or space heater shuts off, the warm air rapidly loses heat to walls, windows, and objects. Within minutes, the room feels cold again. You need constant energy input to maintain temperature. This is why your heating bill is continuous. You are not storing warmth. You are constantly recreating it. Thermal mass heating works on completely different principles. Certain materials have high specific heat capacity and density. They can absorb large amounts of thermal energy and release it slowly over time. Clay and brick are excellent thermal mass materials. When you heat clay, it takes time to warm up because it is absorbing tremendous amounts of energy. But once heated, it radiates that energy slowly for hours. This is thick heat, deep, lasting warmth that persists long after the initial heat source stops. Terracotta is fired clay. The firing process creates a porous ceramic material with excellent thermal properties. It has high heat capacity, meaning it stores lots of energy. It has moderate thermal conductivity, meaning it absorbs heat reasonably quickly but releases it slowly. And it is naturally abundant and cheap. Garden pots cost dollars because they are mass-produced from simple clay. The convection engine design amplifies these properties. When you stack 2 pots with an air gap and place a heat source underneath, you create a chimney effect. The candle or fuel source heats the air directly above it. Hot air rises into the space between the inner and outer pot. As this hot air circulates in the narrow gap, it transfers heat to both pot surfaces through convection. The inner pot gets extremely hot because it is closest to the flame. The outer pot gets moderately hot. Both pots store this heat in their clay mass. Simultaneously, the outer surface of the outer pot radiates heat into the room through infrared radiation. You feel this as radiant warmth. And the heated pots also warm surrounding air through convection, creating gentle air currents in the room. The combination of radiant and convective heating creates comfortable warmth throughout the space. The critical advantage is thermal storage. A typical candle burns for several hours. During this time, the clay pots continuously absorb heat, even after the candle burns out. The stored heat in the clay continues radiating for additional hours. You get warmth long after the fuel is consumed. An electric space heater provides zero warmth when power cuts. The terracotta system provides hours of residual heat from stored thermal mass. Historical use of thermal mass heating goes back millennia. Roman hypocaust systems heated floors and walls with hot air from furnaces. The masonry absorbed heat and radiated it into rooms for hours. 19th century homes used massive brick or stone fireplaces. The brick absorbed heat from fires and radiated warmth long after fires died. Scandinavian masonry heaters burned wood intensely for short periods, storing heat in tons of masonry that kept homes warm for 24 hours. Indigenous peoples worldwide understood thermal mass using adobe, stone, and clay structures that absorbed daytime heat and released it at night. The principle was universal before fossil fuel dependency. You built thermal mass into your home. You heated it periodically with whatever fuel was available. The mass stored the heat and kept you warm. This created thermal sovereignty. You were not dependent on continuous energy supply. You had a thermal battery. But thermal mass heating has a problem from a corporate perspective. It requires no recurring purchases. Once you have the thermal mass, you just need occasional fuel. And fuel can be anything: wood, charcoal, even body heat in well-insulated spaces. There is no way to build a subscription model around it. Worse, it makes people resilient to grid failures. If you have thermal mass and a small amount of fuel, you can survive winter blackouts comfortably. The energy industry faced this problem as electrification expanded in the early 20th century. They needed to create dependency on grid power. They marketed electric heating as modern, clean, convenient. Just flip a switch. No smoke, no ash, no effort. Central heating became the standard. Thermal mass was forgotten. Homes were built with thin walls, no masonry, no heat storage. You became completely dependent on continuous energy supply. By the mid-20th century, most Americans had no concept of thermal mass. Heating meant paying utility bills. The connection between clay, stone, and warmth was erased from consciousness. Garden centers sold terracotta pots for plants. No one mentioned their thermal properties. The knowledge disappeared. Here's what happens when you follow the industry's advice. Winter arrives. Your home gets cold, you crank the thermostat, your furnace runs constantly, your gas or electric bill explodes, you try to save money by lowering the temperature, but then you are cold. You buy an electric space heater for $100 to heat the room you use most. It runs constantly, adding $50 monthly to your bill. You are still dependent on grid power. If power goes out, you freeze. You have no resilience, you're trapped in the subscription model. Now I'm going to give you the exact method. But first, critical safety warnings that are absolutely non-negotiable. This method uses open flame indoors. Open flames produce carbon monoxide, carbon dioxide, and other combustion products. Carbon monoxide is an odorless, colorless gas that kills. It binds to hemoglobin in your blood, preventing oxygen transport. You suffocate at the cellular level. Carbon monoxide detectors are mandatory. If you do not have working carbon monoxide detectors in your home, you cannot use this method, period. Open flames are also fire hazards. Candles and fuel sources can tip over, ignite nearby materials, or cause burns. You must maintain clearance from all combustible materials. You must never leave the system unattended. You must have fire extinguisher nearby. You must understand fire safety principles. This method is for emergency supplemental heating only. It is not a replacement for your primary heating system. It is not for overnight use. It is not for heating your entire home. It is for providing supplemental warmth to a single room during daytime hours when you are present and alert. If you try to use this as primary heating, run it overnight, or leave it unattended, you are creating life-threatening conditions. Ventilation requirements. You must have adequate ventilation. Even with a small candle, combustion consumes oxygen and produces carbon monoxide. Crack a window at least 1 inch. Use this in a room with good air circulation. Never use in a sealed space. Never use in a bedroom while sleeping. Never use in a vehicle or RV without extreme ventilation. The amount of ventilation needed depends on room size and burn time, but always err on the side of too much ventilation. Legal and insurance considerations. Some jurisdictions prohibit open flames in residential buildings. Check local codes. Your insurance policy may not cover damage from improvised heating devices. Understand the risks and legal implications before proceeding. If after all these warnings you still want to proceed, here is the method. This is strictly for emergency situations where you have no other heat source, and you can maintain constant supervision with proper safety equipment. Materials needed: 2 unglazed terracotta pots, 1 large, approximately 10 to 12 inches diameter, 1 smaller, approximately 6 to 8 inches diameter. They should nest with a gap between them when stacked, 1 clay brick or several fire-safe bricks to create a stable platform, one or more tea light candles, or a small sterno-style fuel canister designed for indoor use. Fire-safe surface like a metal tray or ceramic tile to place everything on. Carbon monoxide detector with fresh batteries. Fire extinguisher rated for all fire types. The pots must be unglazed terracotta. Glazed ceramics may crack from thermal stress. Painted or treated pots may release toxic fumes when heated. Plain terracotta from garden centers works. Cost is typically $1 to $3 per pot. Setup location: choose a stable, level, fire-safe surface away from all combustible materials. No curtains, furniture, papers, or flammable items within 3 feet. Place on a non-flammable surface like concrete, tile, or metal. Do not use on wood floors or tables. Ensure the area has good ventilation, and your carbon monoxide detector is functioning nearby. Assembly: place the brick on your fire-safe surface. This creates a stable platform and elevates the heat source. Light your candle or fuel source and place it on the brick. The flame should be stable and not flickering excessively from drafts. Place the smaller terracotta pot upside down over the candle, resting the rim on the brick. The pot should not sit directly on the surface. There must be an air gap at the bottom for oxygen to reach the flame and for combustion gases to escape. Typically, 1/2 inch to 1 inch gap. If the pot has a drainage hole in the bottom, which is now the top, you can leave it open or partially cover it with a small piece of metal mesh. This allows some hot air to escape upward while most circulates between the pots. Place the larger pot upside down over the smaller pot. There should be a narrow air gap between the 2 pots. This gap is critical. Hot air rises from the flame, enters the gap, circulates between the pots, transferring heat, and eventually escapes from the top. This convection current maximizes heat transfer to the clay. Initial heating: the pots will take 15 to 30 minutes to fully heat up. During this time, monitor closely. Check that the flame remains stable. Ensure no smoke is accumulating. Verify your carbon monoxide detector is functioning. Feel the outer pot periodically. It should get warm to hot, but not so hot that it immediately burns skin. If the outer pot becomes too hot to touch, reduce the heat source or improve airflow. Operation: once the system is fully heated, you will feel radiant warmth from the outer pot and gentle warm air rising around it. The room temperature will gradually increase. A single candle system might raise a small room temperature by 5 to 10 degrees Fahrenheit over several hours. Multiple candles or larger fuel sources produce more heat, but also more combustion products and fire risk. Duration and refueling: tea light candles burn for 3 to 4 hours. Sterno canisters vary by size. Plan to monitor the entire burn time. When fuel is exhausted, the clay will continue radiating stored heat for additional hours. You can allow the system to cool completely before relighting, or carefully add new fuel while maintaining safety protocols. Post-use: after the flame is extinguished and the system is cooled, remove the pots and inspect for any cracks or damage. Clean any soot buildup. Store the components safely. Advantages and limitations: the primary advantage is emergency heating capability without grid power. If you lose electricity in winter, this provides warmth. It is also extremely cheap to build and operate. The primary limitations are safety requirements, supervision needs, and limited heating capacity. This is not a convenient daily heating solution. It is an emergency backup. Effectiveness depends on room size, insulation, and outdoor temperature. A small, well-insulated room will warm significantly. A large, poorly insulated space will see minimal temperature change. This works best as supplemental heat in the room you occupy, not whole home heating. This is a $3 investment that provides emergency thermal sovereignty when the grid fails. No $1,500 annual heating bills. No dependency on utility companies. No freezing during blackouts. You have just reclaimed the thermal mass principle that Romans and pioneers used before the energy industry turned warmth into a subscription service. And once you understand that this is possible, you start to realize that many of the other systems you depend on are built on the same model. Infinite energy dependency replaced with thermal mass. Continuous purchases replaced with one-time thermal batteries. Complex HVAC systems replaced with simple physics. The corporations profiting from your dependency do not want you to know that terracotta clay stores and radiates heat for hours without power. They want you paying $1,500 annually and panicking when the grid fails. But you are not powerless. Every time you use thermal mass for emergency heating instead of surrendering to grid dependency, you are reclaiming thermal sovereignty. You are refusing to panic during blackouts. You are choosing physics over subscriptions. And you are using knowledge that ancient engineers had and that modern energy companies deliberately erased. True self-reliance means not panicking when the winter grid fails. Your home should be a fortress of thermal sovereignty, not a place where you freeze without corporate energy. By using this $3 Pioneer solution for emergency situations, you reclaim control, protect your family during crises, and keep your hard-earned money exactly where it belongs. The modern world has convinced you that you are helpless without grid power, that you cannot survive winter without $1,000 HVAC systems and continuous energy bills, that using thermal mass is primitive and dangerous. but the physics proves otherwise. Clay stores thermal energy. Convection amplifies heat transfer. Radiation provides lasting warmth. Ancient Romans heated entire buildings with these principles. 19th century pioneers survived brutal winters with brick ovens and masonry. They used knowledge that was common sense before fossil fuel dependency created the energy subscription model and erased thermal mass from building design. That knowledge was systematically hidden from you, and now you have it back. Use it responsibly. Respect the fire safety requirements. Understand the carbon monoxide risks. This is serious emergency equipment, not a casual convenience. And remember that every system trying to make you dependent is terrified of the moment you realize you do not need them. The $3 terracotta pot at the garden center is more powerful than $1 billion in HVAC advertising. Because the truth is simple. When you understand thermal mass, you do not need the subscription. This is the lost blueprint. The vault is open. The knowledge is yours. Take your thermal sovereignty back.